Here you see f02r, f02r a function, and obviously this is a function of f, so we write fx equals to, and here this interval 0 to, this interval 0 to is split into sub intervals 0 to 1, 0 to 1, and 1 to 2. And in the question it is given that for 0 to 1 polynomial is of degree 2, at most 2, bx plus c, and for this interval from closed interval from 1 to 2 the polynomial is a cubic, at most cubic. So here we can put some other, suppose a b c d, here d x cube plus e x square plus fx plus g. Now we have written the function according to the restriction of the question. Here is d, this thing is d. Now let us apply the conditions, other conditions of the question. You see here f0 is 0, and you know x equals to 0 falls in this interval, so we choose this one. f0 is 0, so putting 0 for x in this quadratic equation, we have a into 0 square plus b into 0 plus c equals to 0. This ensures that c is 0. So our modified function will be fx equals to ax square plus bx, where x belongs to closed interval 0 to 1, and dx cube plus ex square plus fx plus, here fx means f into x, this is not a function, f into x, and plus g. Here x belongs to 1 to 2. Now there is one more condition in the question. You see here, you see continuous function, continuous, and you see this function is piecewise because there are two expressions for two sub intervals. So we check the continuity at the boundary. Boundary means at x equals to 1, at x equals to 1. So to check the continuity, we do LT f x tend to 1 minus equals to LT fx x tends to 1 plus. 1 plus means some just greater than 1, and this should be f1. And using this we have a1 square plus b1 equals to d1 cube plus e1 square plus f1 plus g, and so a plus b equals to d plus e plus f plus g. Here you see 6 symbols, 1 2 3 4 5 6, and any symbol, suppose a for the time being, can be written as a linear expression of other 5, that is D plus E plus F plus G minus B. Here you see 5 symbols, here is the remaining, and this symbol A is expressed as a linear combination of these 5. So A is dependent on D, E, F, G, H, and D, E, F, G and B, these 5 are independent. So the dimension of B is 5. These independent 5 symbols. So the dimension of B is 5. 5 is the right answer.